So for number 14, it says use Newton's method. Now remember that Newton's method is we're gonna guess some x value, which we'll call x sub 1. All right, and then we're gonna go through this process where the next number, right, is equal to the previous number plus, or no, I'm sorry, minus f of x. So we got x sub n minus f of x sub n of f over f prime of x sub n, like that. Okay, that's Newton's method. So if I have x minus, and so we graph this. First of all, graph it. Whoops. First of all, we graph it. So if I come in here, what is the equation? Clear it out. We've got x raised to the third power minus x minus 1, and we want to see when that, when that equals 0. Why is that being silly? All right, equals 1, graph it. And so it looks like it's a little bit greater than 1. It's between 1 and 2. That's where it crosses the x-axis, is between 1 and 2. So I could start with x equals 1, right? So if I start with x equals 1, then I plug it in. Now we said that the easy way to do this, to find the next number, to kind of copy this algorithm, because this is kind of an algorithm, because this will generate one number, that'll generate another number. In other words, if I said x sub 1 equals 1, then I'll crank through this process and get x sub 2, and then x sub 3. And then when the number starts to repeat itself, then that's the solution, right? You guys remember that? We did that in class. So for your test, I made you guys do it by hand on your homework, but then I showed you how to do it on your calculator. So when you take the AP exam, you don't have a lot of time. So for your test, I want you to do it on your calculator. So do you guys remember how we did that? We let y1 be the equation, and what do we let y2 be? The derivative. So what is the derivative of y1? 3x squared minus 1, right? Is that right? Okay, so then what we did is when we got here, we plugged in the algorithm. Well, the first thing that we need to do is we need to say that we're going to start with x equals 1. So I'm going to store, it's 1 store x is what I did. So I screwed that up. It's 1 store x, like that. Now what that means is right now your calculator thinks that whenever I plug in an x, it just treats it as the number 1. Now this algorithm says that whatever x is, I can get the next x by taking the current x and adding it to the function which we stored in which place? y1, right? So I go vars, y vars function y1 divided by vars function y vars y2. So that's the same as this stuff here, minus the function over f prime. y1 is the function, y2 is f prime. And then what do we want to do? Oh, it's got to be minus, not plus, right? So this has to be a minus sign. Oops, this one has to be a minus sign. And then what do I want to do with that when I'm done? Store it to x. So if I hit store x, now what this is going to do is right now my first number is 1. Then my second number will be x sub 2, whatever that number is, then x sub 3. So I'm going to move this over here and maybe make it a little smaller. Whoops. Make it a little smaller. All right. So we're starting off with 1. We hit enter. Now what do I have? 1.5. All right, we're doing good so far. If I hit enter again, what do I get? 1.34. 1.34. If I hit enter again, I get 1.32. So x sub 4 equals 1.325. So it's going to be about 1.2, right? Hit enter again. X sub 5, 1.3247. And I just keep hitting enter until it starts to repeat itself. So somewhere way down here, x sub something, I get 1.324717957 using Newton's method. Okay, how do I verify that?
Find the zero.
Yeah, just let the calculator do it. Well, the calculator uses Newton's method to approximate to 0. What do I want to see on the test? This stuff. Just 3 or 4 terms. So which one is it?
D.
You guys have any questions on this one? Yes.
So if we were to like write it out by hand for like the first one to get x sub 2, would it be 1 plus 1 cubed minus 1 minus 1? Is that what like you guys all?
Yeah, so that's a good question. So like, if you were to write it out by hand, x sub 2 would equal 1 minus 1 cubed minus 1 minus 1, right? That's the numerator, and all over f prime, which was 3, 1 squared minus 1.
Okay.
And if you crank through that whole thing, you would get 1.5.
Okay.
So we're just letting the calculator do this stuff. That's a great question. Now, if you want to do that for 1 or 2 problems, you can.
I just don't know if I'll be able to remember how to do the calculator.
I might write the x store y1 y2 thing on the board if you guys remind me. Okay. Any other questions? Yes.
How do you know it's like the 6th number? Because it looks like C is the same as the 4th number.
It doesn't matter if it's the 4th or 5th. What we want to do is just keep doing Newton's method until the number repeats itself. So technically, because those 3 are the same, I said, all right, that's what it's got to be, because now it's repeating itself. What's really going on there is that if you keep going in the decimals, like the 9th or 10th decimal over, that's what's changing. So it's changing if you go on forever with the decimals, right? But, you know, when you've got like, this is 1, 2, 3, 4, 5, 6, that's like to the 10 millionth, right? So that's good enough. That's a good enough answer. And that'll work no matter what. And one thing that we didn't see in the homework, but I'm glad it showed up on this test, is sometimes it'll go larger than the 0 and then come back down. And that's okay, that's the process. What it does is it zooms in on the 0. Okay? Any other questions? Those are good questions.